Hello friends, welcome to Joy of Life. So today we are at the 10th episode of System Design Fundamentals, and on the last episode we have talked about caching. We have covered the basics part, and today we are going to deep dive and understand in much more details. We are going to dig in few of the areas and find out more about caching. We are going to dig deep in some of the areas and find out the pros and cons of using the caching or the problems we might face and try to see how to resolve them. So we have a bunch of comments here as well. John Wick says, great video. Thanks, John. Your comments always means a lot to me. Nishant Shah says, thanks. Good explanation. I'm glad, Nishant, that you liked it. Do let me know if you have any particular question. Shubham says, awesome. Could you help me with picking up the best caching solution for my use case? Which kind of cache is good if the use case is about updating customer profile related information after each transaction activity done by him? So Shubham, it's not about the solution, but it's about the strategy. So here I can understand that you have a scenario wherein your customer profile is important and you are trying to avoid the stale data, right? You want the data to be consistent, right? So there are some strategies like write-through cache that you can adapt in order to make sure that your data is never stale and your data is always right. So in this video, we are going to cover all the caching strategies that we use in order to update. So Shubham, we are going to talk about all the strategies, including the write-through, which is recommended for your use cases where you are trying to avoid the staleness in the data. So do go through this episode, and in case if you have any question after the end of this episode, do let me know. I would definitely give you detailed answer about the same. So with that, let's jump into more advanced caching and let's talk about the different strategies that we have. If you guys have any questions, doubts, please do shoot out over here and I would try to answer them. And even if you don't have a question for me, just drop a note for me to understand that you have gone through the episode, you have liked it or not, if you have any suggestions for me. So with that, let's go ahead and explore more about the caching that we have done so far. Let's dig deep in some of the areas. So first area is that I have talked about the server and the cache, right? Now this server is not a single piece of system, right? It will be multiple systems. So it would be something like this. You have this load balancer over here. This is our load balancer, and we have multiple server, not a single server that we have seen in this system, right? Now talking about the cache, where would the cache be? Will it be inside the system in each one of the system, or it could be one system that is accessed by all these systems, right? It could be in both the places, but each of the approach has its own problem. So let's see what is the problem, right? So if the cache is inside this system over here, it is inside this system, let's say, maybe something like this. With the approach like this, where we have the cache inside the server, the problem is that when this machine goes, when this machine is dead, or when this machine is out of the network, or it could be decommissioned, or it could be anything, right? When this machine dies, it goes and take the cache to its grave, right? All the data that is stored in the cache is actually lost. We cannot recover that, right? Now another problem could be when a new machine spins up. So let's say when this machine comes over here, what will happen is it will have a cache of its own, but the cache will be empty, right? There is no data inside the cache. So this could become one costly operation as well, right? So there is no data in this cache and this is quite empty. The problem with this approach is that we are storing the same data. So maybe the same data is stored in all the caches, right? Let's say each one of this cache is holding 1 million entries, right? So there are 1 million entries each per server, I would say. Now the problem with this approach is that there will be common data across all of them. About 50 or 60,000 of the data that is stored over here is also stored over here, maybe also stored over here. There could be an overlap between them, right? So it can become costly. So we saw that going with the approach or storing the data with the approach like this is that we are losing everything, right? We are losing everything when the server goes down. We are getting an empty cache when a server comes up. But the benefit is that since the cache is very close to the server, the time will reduce to a great extent. Another approach could be keeping the cache as a global cache. So all of them could use this cache and you don't have the problem that if this machine goes down, there is no impact on the cache. The cache continues to perform and work as it has been. When a new system spins up, when we have a new server over here, the problem that we faced previously is no more there, because it is accessing the same cache as this one and it already has the data, right? And at the back of this we will have our data store. So let's say our DB is over here. So this will look something like this. And it's not that you have to choose between this in the server caching or the global cache. You can have both of them. You can have a caching at this level and you can have a caching at this level. So if you don't find your data in this cache, then you can go and find your data in this main cache, right? So you have a local cache as well as a global cache. So this is two layer of caching that you are doing, and definitely DB is your source of truth where your main data is there, right? But again, caches are not very cheap. They are costly. So you have to judiciously take a call on what you are trying to save and what benefit it gives to your application in terms of caching the data in so many places, right? So you need to choose which one is best suited for your application, right? Some application might be quite demanding. In those cases, you might have both, or you might have only one of them depending upon the use case that you have. You might not have a cache as well. That could be another possibility. So we talked about a scenario wherein a machine comes up and you have your cache which is completely empty, right? So this is more of a lazy loading. You can say that initially if everything is empty, and as and when you start accessing your data, you build your cache, you build up the data, you evict the data, you put the new data. Or what you can do also is to warm up your cache. You can put the data, if you know what are the most accessed data, you can put them and spin up the server accordingly. So it is completely up to you how you are going to deal with your cache, right? Let's say I have a user whose name is Joy, and the ID is, let's say, 123, right? So this is my user ID. This is the user data. I'm from India, and lot of details are there, right? So let's say Uber, right? So I have a balance, how much amount of money I have on my wallet and all those things, right? And every time I get a request for this profile, I am caching it over here. So in this cache, cache over here, we have a entry with the user ID 123. This is my key, and in the value I have the entire object of me, a JSON object, you can say, with all these attributes, name, balance, and whatever, right? Now the first time the request has gone to this server, so there was nothing in the cache, so it went and checked on the global cache. It wasn't there. It went to the DB. So my data is cached over here. So I have another entry 123 and some data in this cache. The request came to this server, so this was present in this cache as well, right? And next time there has been update request. I wanted to change the name from Joy to Joydeep, let's say. I wanted to do that. So the first request went over here. The second request went over here. Now it did not get anything in the cache, right? So first it need to fetch the profile. So it went to this cache where it got a 123. It got the data, and it has updated the data. So what it did is, in this cache, he has put the key and the value. So once again, the key is 123 and the value. So here we had Joy, here we had Joy, and here we have Joy. And it performed the update operation, changed it to Joydeep. So this cache is updated. This one is updated. The DB is updated. Now you see this guy is holding a stale value, right? This could be a big problem. So I have just shown you with a non-sensitive value, which is name, right? So it was fine. What if it had been balanced? So let's say it was $10 here, 10 over here. He has spent $5. So 5 was reduced and the balance is 5 now. He updated it here as well, but he's still holding 10, right? So there is a big problem with the cache when the data becomes stale, right? For some of the data we don't care, but for some of them we do care, right? Just we have seen the balance. For name it might not matter that much, right? But for balance it could be a big business loss. So with cache, the biggest problem is evicting the data. How you need to evict, when you need to evict is completely up to your application, right? So every kind of data will have a life, and we need to understand by the nature of the object what kind of life it is having. So let's say I am using the user's Aadhaar number to get the profile from Aadhaar portal, right? So I can store this data even for 15 days. It doesn't seem to change that often, right? But in case if I am storing your balance in your account and all, I would be very careful. I will have a very short TTL. Again, TTL means time to live. So here TTL was 15 days. I'll have a very short TTL, and in time what I'll do is I will evict the data myself. I will only make sure that I am cleaning up the data. So whenever a request comes over here, so these kind of data I would rather prefer to store in a global cache rather than storing it in the local cache. So local cache will increase the complication. The global cache, on the other hand, could provide some security in terms of staleness of data compared to the local cache, right? If the data is not likely to be changed that often, in that case, I will be going for the local cache or the in-memory cache or the server cache. If the data is frequently getting modified and the data is impactful, in those cases, I am not going to store the data in the local cache or even in any cache. I will query up my source of truth, which is my database, right? I won't rely on any of the transient or intermittent storage like a cache, right? Once again, whenever you're caching, take a judicious call on what type of data you're caching, what would be the eviction time, what would be the TTL, how to evict, when to evict. All those things plays a very critical role when you are caching a data. So let's remove these caches for now. So let's say we have only the global cache over here, and let's understand what is the problem with this cache. So if your data is found on the cache, it is called a cache hit. And if your data is not found on the cache and you have to go to your database in order to get the data, it is called a cache miss. You're missing the data in your cache and you are going to hit the database. So there are several strategies in which we update the cache or evict the data from the cache, read the data, write the data. So let's understand those patterns by which we use the cache. So the first one is called cache aside. So this is one of the most commonly used caching strategies in the application. In this strategy, the cache sits aside. So the cache is over here, and the application which will talk to the cache, and if it doesn't get the data from the cache, what it will do is it will make a call to the DB. So that diagram doesn't look like this. In actual, the diagram looks something like this. So first it will check in the cache, and if it doesn't find, it will go ahead and check on the database. This is also known as lazy loading. So basically what will happen is the first time you want to access the data, it will lead to a cache miss, and the subsequent request will be a cache hit. First time it will go to the cache, it won't find the data there, so it's a mess. So it will go to the DB and it will take the data from the DB and put it back into the cache. So it's a lazy loading, and the subsequent request will have the cache hit, so the data will be found in the cache, and this approach is also called lazy loading. This is very common where you have a read heavy application. So you wanted to read a lot of data. So let's say application like Twitter. If a celebrity goes out and makes a post, so the write is done once, but the read happens quite a lot of time. Or Facebook, right? Just think a post from the president of US or the prime minister of India, they'll have a lot of views, right? So you will have it on the cache, will not go to the database all the time. So we'll load the data from the cache. So what are the benefits of using this cache aside? So there are two major benefits. So the first one is that even if your cache fails, right? Let's say this guy completely fails. This has some outage. This is completely down, right? In this case, you still serve the data. Application works as expected, but it will degrade in terms of performance. So performance will go down definitely, but your application will still continue to work, right? Another big advantage of this approach is due to lazy loading, only requested data is cached, which avoids filling up the cache or the flooding of the cache with the data that is not being requested. So that is a very big plus sign, right? I don't want to cache or store something into my cache, the data that is not being accessed, right? But there are some downside to this as well. So the first one is each time data is accessed the first time, right, it makes 3 trips, right? So first it goes and checks here, it doesn't find it, it goes and checks in the DB, it finds the data, it gets the data, and again it goes to the cache in order to store the data. So each time a cache is messed, there are 3 trips that happens, right? So let's say if it takes around 10 milliseconds for each one of these trips, let's say these are all mils, so it will cost you 30 mils for the first request, right? If I have only gone to the DB, it would have been, let's say, 10 milliseconds. And with this approach, it will cost me around 30 milliseconds. So that is a big number, right? So it is 3 times more than the normal. So we have seen this earlier, right? So there is a high chance that this data goes stale, right? This can be mitigated by using a TTL. So once again, we have talked about TTL. So you can use a TTL, a shorter TTL or a longer TTL based upon the nature of your data to force the server to go for an update. So let's say I am storing this record for 30 minutes, right? So after 30 minutes, the cache will evict the data and the next request will be again served from the database and again returned to the cache. If it is a data that is prone to changes, right? If it is not prone to changes, we can have a longer TTL. Another big problem with this approach is initially the cache is empty, right? So lot of calls will be empty request hitting the cache initially until the data is loaded up into the cache. So we have another strategy which is called read through. Read through is quite similar to the previous strategy, cache aside. Instead of managing the database by ourselves, what we do is we give the database control to the cache provider. So the diagram looks something like this. We won't have this line. So this is controlled by the cache provider. It's the responsibility of the cache provider in order to take care of the database operations. So both the approach, the cache aside and the read through loads the data lazily, right? So in cache aside, the application is responsible for fetching the data from the data store and populating into the cache. So this application will get the data, store it into the cache. In read through, the logic is usually supported by the library or the standalone cache provider. So this operation of getting the data from the DB and putting it into the cache is left with the cache provider, right? So unlike cache aside, the data model in the read through cache cannot be different than of the database. So again, what we can do in the previous model is, let's say this model is I can get this object, right? I can remove 2 fields from here, change 2 fields, add another 3 fields and have it stored in my cache, right? I can do that. But with read through, we cannot do that. So the schema that is used over here and the schema that is used over here has to be the same. I cannot add any additional fields or I cannot remove any fields from the schema of the database. Apart from that, both the caching is more or less the same. Again, it's for a read heavy application. It has similar pros and cons with the cache side, just that we are offloading the database to the cache provider. That is the only benefit over here. And what we are trading off is that we cannot change the schema. The schema will remain the same. Then we have the write through cache. Coming to the write through caching strategy over here. In this strategy, what happens is the cache acts as the main data source to read and write. So this cache acts as the main data source. The cache basically sits between the application and the data store. So this is our data store, this is our application. This guy sits in between. This server over here goes and updates an entry into the cache. Now what will happen is the cache will synchronously writes the entry to the data store. So this operation between the cache and the data store will be a synchronous operation. And then the cache returns the value to the application. So write through strategy slows the overall operation due to the write operation, which writes data to the cache first and then synchronously to the data store. And once the data is written to the data store, definitely the subsequent requests are going to be very fast. The advantage with this approach is the data in your cache is never stale. Since the data is written to the cache and synchronously written to the database, it is never going to get stale, the data. A big problem with this approach is most of the data that is written onto the cache might never be read, right? It is not assured that whatever I am putting into the cache and then synchronously to the DB might not get accessed at all. We might end up storing a lot of data which will not be used or read back by the application again. So that could be a big problem in this approach. Another strategy we have is write behind or write back. So in this approach of write behind or write back caching strategy, the data is written to the cache. So the data will be written over here into the cache and the response is sent back saying that the operation is complete. We are not going to wait for this data to go from the cache to the DB that we have seen in the previous approach. So this data from the cache to the DB is updated asynchronously. So this is going to have a good improvement in terms of your write performance. So if you have a write heavy application, you can use this strategy wherein you will send the response back to the client once you have done writing to the cache. So it makes sense to have this kind of strategy for your write heavy applications where you have to do a lot of writes compared to the reads. So definitely one of the plus point for this approach is having a better write performance, and there are some drawbacks to it. There is a possibility of data loss. Why? Because if the cache goes down before writing to the DB, all the data that's not been written to the DB yet is going to go away. So we are compromising on the consistency part. We might lose some data. And definitely when we are having a system like this where we are asynchronously doing the update from the cache to the DB based on some time duration using a batching or something like that. So definitely it's going to be a more complex system compared to the write aside, read through or write through. So it's going to be a little complicated compared to them. Then we have refresh ahead. So in the refresh ahead strategy, which is not quite common, the cache is configured in such a way that it automatically refreshes any recently accessed cache data or entry prior to its expiration. So basically the cache tries to predict the data which is likely to be accessed in the near future. So refresh ahead can result in a reduced latency. Basically the intent is that the system tries to predict if the data is going to be accessed again soon. So before the expiration of the data, the cache ensures that it refresh ahead of its expiry. So definitely reduced latency is going to be a plus side of this, but there could be a negative or downside to it as well. Not accurately predicting which items are likely to be needed in the future can result in reduced performance. So let's say you start removing or deleting or evicting the data that you require, right, instead of the data that you don't require. So you lose the performance, you reduce the performance in those cases. So we need to be very cautious when we are going to have a strategy like that. So with that, we have talked about all these 5 strategies. They are pretty important, as you understand now that it might vary from system to system what we are going to need, when we are going to need which strategy. So all of the strategies are important and we need to make the right call which one applies or fits my scenario. So as we go through this episode, I hope you start realizing that how important it is for us in order to keep the right data into the cache and to evict the stale ones, right? There are several eviction policies that we have talked about, like first in first out, then we have the last in first out, then least recently used, which is one of the most common one, right? Then we have the most recently used, then least frequently used, random replacement. There are several strategies. So you need to take a call how you are going to configure your cache so that you make sure that you are sending the right data back from the server to the cache. So I hope this has given you some idea of the caching, the in-memory caching that we have also seen, that we put the cache at several layers. And previously on the video, we have talked about a very high level design of the system. So here are the 5 strategies that we have discussed, starting from cache ahead, read through, write behind, refresh ahead. So do go through and read about them in a lot more detail. So I hope I have given you the basics of all of these concepts, where to start digging from. And do choose your strategy judiciously when you are choosing a particular strategy based upon the scenario you have. In case if you have any doubts or questions, do put them in the comment section below. Do let me know. In case if you are struggling to figure out anything, do reach me out in person on social media like Facebook or LinkedIn, or do comment in the video. I could try my best to help you out there as well. So with that, I'll end this episode over here. So once again, do write and let me know your thoughts and suggestions on the video. So bye bye, take care, and see you soon again.